Hi students, welcome back to the channel. Today I am going to discuss about the very important chapter on calculus, that is an integrals. Today I am going to discuss about the introduction of the integrals. First of all, in the calculus there is a two main groups are there, that is an differential calculus and integral calculus. Already we discussed about the what is the differentiation, what is the application of differentiation. Today we are going to learn about the integral calculus, that is the integrals. First of all, I will relate the what is the differentiation, what is the integration. What we are finding in the differentiation, what we are going to find in the integrals. Okay. Now, differential calculus, what is the meaning? Differential calculus is based on the concept of derivatives. Okay, it is based on the its derivative. For example, finding the slope of the tangent. If we differentiate the curve, what it will curve? If we differentiate the function f of x, what it is indicating is that it is an slope of this tangent at particular point at P. That is an indicating the derivative of an f of x. Okay, na? And also it indicates the rate of change of function. It means that here, for example, volume is there. What is the rate of change of volume? What is the volume is decreasing with respect to time? It shows derivative, it's indicating. And also one more example, what is the speed of an object? What is the rate of change of distance, speed? It means that derivative is indicating the slope of a tangent and rate of change of function with respect to t or another variable. Okay, na? But in the integrals, integral calculus deals with finding the area enclosed by the curve f of x. This is a function f of x, then this is the area. What is the integration meaning is that it should find as an area bounded by the curve y is equal to f of x. And also one more, finding the original function from its derivative. Finding that is called as a indefinite integral. This is called as a definite integral. I will tell you. Okay. Now integration what is deals? It deals the area bounded by the curve and getting as an original function from its derivative. That is a two case. Okay. Na? Then the fundamental connection between connection antiderivatives. What is the fundamental relation between the differentiation and integration? There is a function f of x is there. If we differentiate, you will get as a function small f of x. Okay, na? If you integrate that function, then what you will get? You will get again original function. If we differentiate capital f of x, you will get as an small f of x, that is a function. Again, if we integrate that one, you will get as an capital f of x. It means that differentiation and integrations are reverse process. Okay. Then finding the original function from its derivative is called as an antiderivative, otherwise integration. Okay. Next, now what is antiderivative? If f dash of x is equal to f of x, if you differentiate the f of x, you will get as a one more function small f of x. Then capital F of x is called antiderivative of or primitive of small f of x. Then integration is the process of finding antiderivative. Okay, na? Finding the antiderivative from its derivative is called integration. Then indefinite integral. The collection of all the antiderivatives of a function is called its derivative or its indefinite integrals. General formula: integrate f of x dx, okay, then you will get as a function f of x with the constant c is called constant of integration, otherwise arbitrary constant. Be careful, if you differentiate any function, you will get as only one output, that is an f of x. Other, if we integrate any function f of x, you will get as a family of n curves. Be careful. Why? What is the relation for that one? We will introduce. If we differentiate the function, you will get only one output. If we integrate the function, you will get as a family of curves. That's what we are introducing, the one more constant, that is an arbitrary c. That is called constant of integration. Now, there is a two types of integrals are there. First one is indefinite integrals. This is used to find as an antiderivatives. One more is definite integrals, used to calculate the exact area over the given interval. Definite integral is used to find the area under the curve. Indefinite integral is used to find as an antiderivative from its derivative. Okay. Next, what is the relationship between the differentiation and integration? Differentiation and integrations are inverse process. Differentiation finds the derivative, integration recovers the original function from its derivative. Okay. Next, final conclusion from this statement is the integration is the inverse process of differentiation and is used to find antiderivatives and calculate the areas under curves. Area under curve is an definite integral. Find the antiderivative is called as an indefinite integrals. Okay. Next, what is an integration? Definition of integration. Integration is the inverse process of differentiation. If the derivative of a function is known, integration helps us to find original function from its derivative. This process is called integration or anti-differentiation. Okay. Next, I'm going to use some basic example to find an antiderivative, otherwise integration. Now we know that differentiation of sin x is cos x. Same way, integration of cos x dx is sin x plus c. Next, similarly, differentiation of x cube by 3 is an x square. Differentiation of x cube is 3x square. By 3 is the 3 get cancelled, that will become x square. Same way, integration of x square is x cube by 3 plus c arbitrary constant. Next, what is the differentiation of e power x? That is an e power x. Same way, integration of e power x dx is e power x plus c. Next, what is a constant? Why you are keeping a constant? Every indefinite integrals contains a constant c. C is called constant of integration or arbitrary constant. Look at here. Since the derivative of a constant is 0, this derivative of constant is 0. Derivative of f of x is f dash of x. Derivative of a constant is 0. For example, now x square plus 2, x square plus 3, x square plus 5. What is the differentiation of x square plus 2? 2x. What is the differentiation of x square plus 3? That is also 2x. What is the differentiation of x square plus 5? That is also 2x. It means that all the differentiation of all the function is same 2x. Then if we integrate this all things, okay, now if we function, I need all these function, is it right? I need all these constant, is it right? Therefore we are keeping as an constant called arbitrary constant. Hence all the functions differing only by the constant have the same derivatives. Okay, next, general formula. If differentiation of f of x, capital F of x is f of x, same way integration of f of x dx is capital F of x plus c. This is the fundamental formula of indefinite integration. Okay, next, one line complete explanation I can give here, one line summary. Integration is the process of finding original function from its derivative, and general answer always includes an arbitrary constant c. Okay, next, now I'm going to find as an antiderivative of example cos 2x. We know that differentiation of sin 2x is 2 into cos 2x. Now I will keep the cos 2x as it is. I will send the 2 that side, that is an cos 2x is equal to 1 by 2 differentiation of sin 2x. Then if I integrate the cos 2x, you will get as an 1 by 2 sin 2x plus c. Okay, same way, second example, find the antiderivative of 3x square plus 4x cube. We know that differentiation of x cube is 3x square. Same way, differentiation of x power 4 is an 4x cube. Then differentiation of x cube plus x power 4 is an 3x square plus 4x cube. Same way, if we integrate this one, integration of 3x square plus 4x cube into dx is x power 3 plus x power 4 plus c, arbitrary constant. Next, find the antiderivative of 1 by x. We know that differentiation of ln x, otherwise log x base c, differentiation of log x equal to 1 by x. X should not equal to 0. Then integration of 1 by x dx is ln x, otherwise log x plus c. Okay, next, some basic formula you should remember. Then integration of x power n dx is x power n plus 1 by n plus 1 plus c. N should not equal to minus 1. Same way, integration of 1 by x dx is ln x plus c. Otherwise, generally we can say that log x plus c. It should be base e. Next, integration of e power x dx is e power x plus c. Same way, integration of a power x dx is a power x by ln a plus c. A should be the greater than 0 and a should not equal to 1. Next, trigonometric integrals. Integration of sin x dx is minus cos x plus c. Then integration of cos dx is sin x plus c. Same way, integration of secant square x dx is tan x plus c, because we know that differentiation of tan x is secant square x. Then integration of cosecant square x dx is minus cot x plus c. Then integration of secant x tan x dx is secant x plus c. Same way, integration of cosecant x into cot x dx is minus cosecant x plus c. Last, additional standard formulas. Integration of tan x dx is ln secant x plus c. Be careful, these are the different from the differentiation. Integration of cot x dx is log sin x plus c. Then integration of secant x dx is ln secant x plus tan x plus c. It means that in the log always it is an absolute value. That's what I am not telling the modulus. Then integration of cosecant x dx is ln cosecant x minus cot x plus c. Okay, these are the very important basic formulas we should remember to continue with the example. Okay, thank you so much. Bye. Take care.